Hello friends. In this video, I will tell you about the new version of the Zigbee network coordinator from the Ukrainian brand SMlight, the SLZB-06p10, based on the CC2674P10 chip. As of today, this is the most powerful and advanced model among Z-stack adapters. Additionally, using it as an example, I will show you how to install multiple zigbee2mqtt add-ons on a single Home Assistant server. Why might this be necessary? For example, when your network becomes too large and a single adapter can no longer handle it well, or when you need to use devices far away from the first coordinator, on another floor, or even in another building. And this cannot be done via the Zigbee network itself. Another use case is to allocate into a separate network devices that frequently send data updates and may interfere with others. At the time of filming this video, my working smart home system consists of 3 Zigbee networks. More details coming up, but for now, as usual, I ask you to like this video so more people interested in smart home topics can find it, and to subscribe to my channel if you haven't already. The device type is a Zigbee coordinator. Used socks, Zigbee 3.0, CC2674P10. Controller, ESP32. Ethernet, LAN 8720. Serial, CP2102. Antenna, external detachable plus 5 dB. Connections, Ethernet, Wi-Fi 2.4 GHz, USB. Power over Ethernet or USB. Configuration, via built-in web interface, OTA updates for both control and Zigbee modules. In the previous video, where I talked about the USB coordinator SLZB-07p10, I compared 2 socks, the CC2674P and P7. Now I've added a third option to the table, the CC2674P10. Unlike the 2652 versions, it is based on a newer ARM Cortex M33 processor with ARMv8 architecture, whereas the Cortex M4 is based on ARMv7. The new version has received significant improvements in security, such as trust zone support, secure boot, key protection, and a hardware crypto processor. In addition, the new chip has increased both internal and RAM memory. The list of supported protocols has also been expanded. As of today, this is the most powerful and advanced chip in the series. The device comes in a cardboard box, designed in the brand's familiar style. I've been familiar with SMlight products for several years now, and my channel has featured multiple reviews dedicated to them. On the back side, there are brief technical specifications, which I've already mentioned, and a description of the package contents. Everything is very thoughtfully packed. All necessary holders are present. Nothing rattles inside the box, as always. In the set, besides the coordinator itself and the detachable antenna, there are several small items that show attention to detail. In particular, there is a paper template with markings for mounting holes, which will be useful if you choose this installation method. Additionally, there are 2 small screws, a hex key, a couple of double-sided adhesive tape stickers, and even a micro USB to USB-C adapter in case you don't have the right cable. Recognizable case design for the entire SMlight SLZB-06 series, elongated, measuring 160 by 22 by 24 millimeters. Along the entire length are numerous ventilation holes, and on the top side is a button for switching operating modes. An external omnidirectional antenna is used here as well, with a gain of plus 5 dB, which is higher than in the USB versions. The connection is via a standard RPSMA connector. On one of the side faces, there is a USB-C port that can be used both to power the device and to connect it in USB coordinator mode. Though, in my opinion, it's a bit odd to use the network version this way. One of the advantages of this device, and not the only one, is the ability to operate over the network. The Ethernet cable port is located on one of the narrow sides. Moreover, this same port can be used to power the device. It supports power over Ethernet. The bottom cover of the case is removable, and we'll take a look inside shortly. It has the model number, a list of supported interfaces, and the serial number printed on it. I already mentioned in the previous video about the USB version of the SMlight coordinator that the packaging color corresponds to the chip it is based on. My working system, at the time of filming this video, consists of 3 networks, 2 built on SLZB-06 and 1 on SLZB-06p10. Links to the reviews are in the description. I want to note that with the current firmware versions, all of them work absolutely stably. Externally, all these versions are completely identical. The case shape is very recognizable and serves as a sort of signature for the device. They can only be distinguished by the model number on the bottom cover. Using several network coordinators helps solve issues with covering large areas, multiple floors, or even separate buildings. It's important to understand that each coordinator creates its own Zigbee network, but at the smart home system level, all devices will interact with each other. Let's take a look inside. The cover is held by latches. To remove it, you need to pry it with something thin and firm. Inside is a well-organized board with double-sided mounting. On the left is the RPSMA connector for the external antenna, connected to the CC2674P10 module. Closer to the center is the USB Type-C interface controller, which provides power and communication with the host device. On the right, the Ethernet controller and a full-size shielded Ethernet RJ45 port. Here we see the key microchips that define the device's functionality. CC2674P10, left, the main radio module. It supports Zigbee, Thread, BLE 5.3, and Matter protocols. External SPI flash WIN bond, center, used for storing firmware, logs, or OTA updates. Using separate flash memory allows flexible firmware updates and feature expansion without reflashing the main chip. ESP32, right, a powerful microcontroller with Wi-Fi and Bluetooth. It handles Ethernet communication, interfaces, and logical coordination, and can also perform OTA updates of the radio module. In the right part of the board is the Ethernet port, next to it, a matching transformer, and the HS1602 chip, which performs Ethernet PHY functions. They ensure reliable data transmission and galvanic isolation. Below, an electrolytic capacitor and power filtering circuits that ensure stable operation under network load. On the reverse side are power and protection elements. ABS 210 rectifiers for switching between USB and PO, a DC/DC converter with filters, and a 3.3V stabilization circuit. Markings 06P7 and 06P10 are visible, indicating a universal board for both versions. Now it's time to move on to the practical part. We connect the external antenna. This is how the device looks with it. To power such devices, I use a managed PoE switch from SteamMO with Home Assistant integration, where it provides control over each port and energy consumption data. If necessary, you can reboot connected devices via power. Link to the review is in the description. Jumping a bit ahead, here is the power consumption data. The first 3 ports are my working coordinators, 2 SLZB-06 and 1 SLZB-06p10. The device featured in this review is connected to port 8. The switch displays a power consumption of 1.5 watts. Since the connection is made via cable, there is no need to enter any login credentials. We go to the router interface and look for a new device by name. In my case, the router assigned it the address 192.168.0.229. Let's go to it. We enter the coordinator's own interface. This is another undeniable advantage of network versions over USB ones. By default, the dark theme is enabled, which can be switched using the button in the upper right corner. On the main page, we see 2 columns. The left one contains basic system status information, and the right one, hardware information. Specifically, we can see that the device is currently working in Zigbee coordinator mode and is connected via Ethernet. Just below, we see that there are currently no active connections. On the right, we see the firmware versions of the radio and control modules. The Modes tab. Here, You can choose how the device will be used, as a coordinator, that is, the central node of the network, or as a router, one of its mesh points. There are also toggles for the connection type, Ethernet, Wi-Fi, or USB. The Network Settings tab, by default, the DHCP mode is enabled, which means the coordinator gets its IP address automatically from your Wi-Fi router. Which exact IP address is assigned isn't that important. What matters is that it stays unchanged after connecting to zigbee2mqtt. You can either disable DHCP and set a static address manually, or bind a fixed IP assignment in your router settings. A bit lower on this same tab is the equivalent menu for Wi-Fi. Everything I've said about IP address fixation applies here as well. By default, Wi-Fi is disabled. If you decide to use it, start by scanning for available networks. Then select the desired network. Only the 2.4 GHz band is available, and connect. After receiving an IP address, Ethernet can be disconnected. However, I recommend prioritizing a wired connection, as it is more stable and faster. Use Wi-Fi only as a last resort. Next is the tab for configuring zigbee2mqtt and ZHA. Here are the parameters to be added to the add-ons configuration file, specifically to the serial section and the line to set maximum power in the advanced section. A template of this file for initial setup can be found in the video about installing zigbee2mqtt. Under this video, there will be a template for the second instance, including these settings. ZHA parameters. The coordinator can also work with this integration. The setup is automatic. I also showed how to do this in one of my tutorials. Link in the description. And these are the settings when using USB mode. In case such a need arises, the port number will need to be identified manually. How to do this is also shown in my video tutorials. Further below are the speed and port settings for the connection. We leave them unchanged. There is no need to modify them unless absolutely necessary. Still on the same tab, there is a block for setting the unique 64-bit identifier of the Zigbee radio module, similar to a MAC address. You can check the factory setting, which may differ from the currently set one, shown right here. This value can be changed, which can be useful when replacing a coordinator in an existing network. How to do this? Using USB coordinators as an example, I showed in a previous video. Link in the description. For network versions, the process is the same. In this case, the factory and current addresses are identical and should be, since the coordinator is new and hasn't been used anywhere yet. The Security Settings tab allows you to set up login and password entry. There are also several additional options, such as limiting the list of IP addresses that can connect to the device. If working with a server located in another network, there is an option to set up a VPN connection. Now let's look at the Settings and Tools tab. The first item allows you to set the device name on the network, as well as restart the radio module and ESP32, switch it to firmware update mode, or reconnect it. A very useful and necessary firmware update page. Unlike USB versions, network ones can be updated directly through their web interface. It's important to understand the difference. The core firmware refers to the control module, the ESP32, while Zigbee refers to the radio module, CC2674P10. I do not recommend enabling automatic updates. It's better to keep everything under control. Another advantage, not just a single firmware is available, but a changelog up to version 0.9.9. Versions labeled Dev are for developers. They are intermediate and intended for testing before stable releases. At the time of testing, the latest stable version was 2.7.1. This is the one I will install. We wait a few minutes while the new firmware is downloaded and installed. Let me remind you once again, this concerns the control module ESP32. Therefore, after the update, the device restarts. It then launches with the new version. On the first start after the update, an information window appears, showing the version upgrade and a list of changes. Now let's update the firmware of the Zigbee module. This option is located on the same tab, to the right. The system displays the current version and possible usage modes for the device, so you can install the appropriate firmware version. In this case, we're considering Zigbee coordinator mode. Here too, different versions are available. You can both upgrade and downgrade the firmware version. This can be helpful if the new version turns out to be unstable. The current version at the time of testing is from July 17, 2024. The process is similar. First, the selected version is downloaded. Everything is done directly from the device interface, which is very convenient. Then the installation begins. When you need to update the firmware later, when the coordinator is already in use. First, you'll need to stop the add-on, then update the control and radio modules, and only after that launch zigbee2mqtt. After updating the radio module, a reboot is not required. The device is ready for use immediately. On the main page, in the hardware section, the new versions we just installed are now displayed. Let's take a look at the remaining interface items and move on to installing the second instance of zigbee2mqtt. On this page, you can control the LEDs. They can be turned off permanently or only during night hours. Time zone and NTP server settings for time synchronization are located here. Here you can view the device's operation log. This may be needed for event analysis. In the lower left corner is the menu, which contains many languages in which the device interface can be displayed. I have told you in detail about the coordinator. Now it's time to move on to the second part. This is the same server that I showed in my previous videos about installing zigbee2mqtt and then replacing a USB coordinator on the fly without repairing devices. Link in the description. The settings of the installed instance are saved by default, the path to its directory, and the port number on which this add-on runs. This is its configuration file, which I also showed in the mentioned tutorials. The topic in Mosquito Broker is also set by default. The channel number is 11. PAN ID and network key were generated automatically at the first launch. This is what the topic structure in the broker looks like. One is intended for zigbee2mqtt. It is grouped by the names of connected devices. By the way, right after connecting through MQTT Explorer, this may be empty, and that's normal. Topics will appear as data from devices comes in. The Home Assistant topic, it is grouped by object types, of which there can be many in one device. By the way, it will remain as a single topic. It will just contain data about objects from different zigbee2mqtt instances. The network of the first add-on, which currently has 8 devices, is working fine. Here, let me remind you, a USB Zigbee coordinator SMlight SLZB-06p10 is used. Let's go back and go to the add-on store. We cannot install the same add-on twice, so it needs to be added again. Go to the Custom Repositories menu. If we try to add the same zigbee2mqtt repository link that we used in the lesson about the first add-on installation, we'll get this message. It's not possible to add this repository because it already exists in the store. What should we do? You just need to slightly modify the link, even by 1 character, as long as it still points to the correct repository. In this case, I simply added a slash at the end. That worked. Now I have 2 zigbee2mqtt entries in the list. One is already installed, so it cannot be deleted from here. The other is not yet installed, which is why the delete icon, trash bin, is active. Refresh the add-on store page with the F5 key, and we see that there are now 2 zigbee2mqtt add-on tiles. The installed one is highlighted at the top. If you need a third instance, you'll have to come up with something else. For example, remove the letter S from HTTPS at the beginning of the link. If you need a fourth, you can remove the letter and add a slash, and so on. Any minimal changes that don't affect the repository path, but differ by at least 1 character from the links already added. Proceeding to installation. Just like last time, select the standard, stable version of the add-on. First, it needs to be installed. The system will download all necessary resources and prepare the add-on for launch. After installation, go to the Configuration tab. We need to perform a few preparatory steps. Change the path to the add-on folder. Each should have its own. You can simply add the number 2 at the end. Don't forget to save this change. Just below, the port number. This also needs to be changed, since the default one is already in use. I simply use the next available port. Save this as well. Note that each section has its own save button. It's best to double-check everything. Now we follow the same procedure I showed in the zigbee2mqtt installation lesson. Manually create a folder for it. Naturally, use the name specified in the configuration. Create the main configuration file in it. It's based on the template I've already shown, but with some changes, which we'll now go over. The text version of this file can be found in the description under the video. The topic, specify a different one. You can name it anything. I simply added a 2 at the end, following the directory name. This block can be copied from the SMlight interface, which is exactly what I did. Transmitter power is already included in my version of the template, so no need to add it again. Channel number. You can leave the default, 11. The networks can operate on the same channel. But it's better to separate them by frequency and, for example, set channel 15. It is also a standard channel and supported by almost all devices. Everything else doesn't need to be changed. The link to this version of the template is in the video description. In the Add-ons tab, there are now 2 tiles for zigbee2mqtt. One is still inactive. Let's open it. Now, after all the preparatory steps, the add-on can be launched. You can monitor the startup process in the log. The first launch takes longer than usual. If everything was done correctly, soon you will see this startup message. Don't forget to enable the watchdog option for automatic restarts in case of failure, and also enable display on the left panel. Now there are 2 zigbee2mqtt entries there. They look identical, and as far as I know, there's no simple way to customize their appearance. The add-on has just launched. There are no devices yet. You can go to the settings menu and view system information. The current add-on version at the time of testing is 2.1.3, and the Zigbee module firmware version is also displayed. A new topic has appeared in the broker belonging to the second add-on. It will also create links to its devices in the Home Assistant topic, just like the first instance. In the list of MQTT integration devices, another device has appeared for controlling the add-on itself. It looks exactly the same, but in this case, the coordinators have different firmware versions, and the first one already has connected devices. Very soon, we'll connect something to the second one as well. Here, by the way, is what the configuration file looks like after the first launch. A user account for MQTT access was automatically generated, along with a PAN ID and Zigbee network key. In the coordinator interface, on the main page, one connection is now shown. This is the zigbee2mqtt add-on. The pairing process is standard. Select the desired zigbee2mqtt instance. Click the button in the upper right that activates pairing mode. If necessary, you can specify exactly what to connect to, the coordinator or one of the routers. How to do this was shown in the zigbee2mqtt installation lesson. Here is a small Zigbee network for the second coordinator. There is one router device. Remember, it's best to start pairing from them, and 3 end devices. The network map looks like this. All end devices decided to connect to the USB Zigbee router, although I didn't specify this explicitly. The network of the first add-on remains unchanged. They don't interfere with each other. Here the network map looks like this. Most end devices also connected through routers. Here's how the Mosquito broker structure changed. Each add-on works with its own topic, without overlapping, but links to devices are created in the same topic, Home Assistant. Therefore, in the MQTT integration, the device list is unified from both add-ons. And Home Assistant doesn't care which add-on controls what. All devices can participate in any automation. Also, for the SMlight network coordinators, there is a namesake integration in Home Assistant. It is standard, no need to install it separately. All available coordinators are detected automatically. You just need to select and add it to the system. No additional actions are required. Any number of coordinators can be added here. Right now, aside from the one featured in this review, 3 models that I use are also displayed. From here, some functions we already reviewed in the interface are available. LED control, checking and updating firmware versions for the control and radio modules, restarting the core and Zigbee. Connection information, operating mode, module temperature. All basic info and options are now available from within Home Assistant as well. In my opinion, the network versions of SMlight coordinators are the best currently available for working with zigbee2mqtt or ZHA. By the way, there are also versions based on EFR32MG21 series modules. Convenient, with the ability to be installed separately from the smart home server, including other remote networks. With their help, it's easy to run multiple networks to cover large areas or several floors. Looking ahead, I'll say that multiple servers can be connected to such a coordinator, for example, for redundancy. That's all for now. I hope the video was useful and interesting for you. I'd appreciate your likes. They help promote the video on YouTube. If you don't want to miss new videos, subscribe to my channel. In the video description, I'll leave links to all mentioned resources, as well as my Telegram channels and social media groups for discussing smart home topics. Join in. It'll be interesting. Thank you for watching. See you next time. Peace to all.